Hello everyone, welcome to Tuteetute. Now we will discuss the questions from the signals and systems and EMF in the examination which was conducted yesterday. This is related to SPDCL AE examination. First question is, what is the current gain of a transistor in the CC mode given that it has a current gain of 0.98 in the CB mode? CB mode current gain is nothing but we can take it is alpha CB mode, that means common base configuration. Here alpha is given by 0.98. So common base configuration means the output terminal is collector, input terminal is emitter, and base is common to both input and output. So the alpha is given by output current IC by the input current IE. The ratio between output current IC and input current IE is nothing but alpha, that is 0.98. This was they have given. Now we have to calculate the current gain for the CC configuration. So for the CC configuration, that means common collector configuration, the collector is common to both input and output, base is the input terminal and emitter is the output terminal. Since emitter is the output terminal, the current gain of this particular common collector amplifier is involving output current IE and input current IB. This is the ratio, IE by IB. This is what we have to calculate. So it is equal to, we can take this one as IB plus IC, because we know that IE is equal to IB plus IC, by IB we have to take. So here IB plus IC is divided with IB, that means we will get 1 plus IC by IB, and we know that IC by IB is nothing but current gain of CE configuration, that is 1 plus beta. They have given here alpha, but here what we need to calculate means 1 plus beta. Okay, so what is the formula for beta in terms of alpha? Beta is equal to alpha by 1 minus alpha, that is equal to 0.98 by 1 minus 0.98, that is nothing but 0.98 by 0.02, that is 49. So that 49, if you substitute here, 1 plus 49 is equal to 50. 50 is the answer. This is the current gain of the common collector amplifier. So option C is the correct option. Now the question is related to the operational amplifier. Consider the operational amplifier to be ideal. Ideal means we can able to consider here input impedance is infinity. This is the thing is required for our problem. That's why I have taken that one. In the following circuit, if input is equal to minus 5 volts, find the output voltage. Okay, so input is minus 5 volts. Here input is given, and what is the output voltage? That is what we have to calculate. Basically it is non-inverting amplifier. How can we tell it is non-inverting amplifier? Means it is involving the negative feedback. Because of this because of this 2 kilo ohms, we can able to say that negative feedback is available in this particular circuit. So it is amplifier circuit. Then the input is given to non-inverting terminal. So it is the non-inverting amplifier. If the input is given to inverting terminal through this 1K, that is called inverting amplifier, but it is non-inverting amplifier. And we know that for the non-inverting amplifier, the output is nothing but 1 plus RF by R into V input. Or we can say, by sending this V input this side, V output by V input is equal to 1 plus RF by R. That is the gain actually. So gain is multiplied with input, then we will get the output. For any particular system, we can say output voltage is equal to gain into input voltage. So same thing we have followed here. And here RF is nothing but 2K and this R is nothing but 1K. Here we can able to substitute those things. So 1 plus RF is 2K by R is nothing but 1K. It is multiplied with the input voltage, that is minus 5 volts. So it is equal to kilo ohms will be cancelled. So 1 plus 2 is 3. 3 into minus 5 is nothing but minus 15 volts. So this is the correct option. Next question is also based upon the operational amplifier only. Consider the operational amplifier to be ideal. In the following circuit, determine the voltage V out. So here it is actually related to inverting amplifier case. But here what is there? 2 inputs they have given. So because of these 2 inputs, what is the output we have to calculate. Okay, so and we have to consider in this particular case, because of the presence of the negative feedback, we can say that it is working like a linear circuit. When we consider the linear circuit, superposition theorem can be applicable. That means the overall response due to many inputs, the overall response is the sum of the individual responses. Okay, this thing we can able to apply for the linear circuits. The overall output is the addition of individual outputs, output 1, output 2. Here two outputs I am taking because here two inputs are there. For 5 millivolts, one output we will get. That one we can able to treat like a V out 1, and for 9 millivolts, V out 2 we will get. And whatever the V out 1, V out 2 we got, we can able to add those two to get the overall response, overall output, because of these two inputs applied simultaneously. Okay, so this is called linearity principle or the superposition principle. We can able to apply here because here negative feedback is there, that is applicable. But whenever this inverting amplifier is available, for the inverting amplifier, we can able to say that output voltage is equal to, okay, for output voltage is equal to minus RF by R into V input. This is the output voltage. Okay, so now what we can able to write, V out 1 is equal to minus the feedback resistance is fixed, that is 7 kilo ohm. So 7K by, if you want to find the output voltage due to this 5 millivolts, we have to make this input to is 0. Okay, you can make here 9 millivolts is 0 because individual response we are calculating. So only this 5 millivolts is acting on the circuit. This 9 millivolts should be grounded. So whenever it is grounded, and in the feedback concept, negative feedback concept of the operational amplifier, we need to know about the virtual ground. Virtual ground is nothing but whatever the voltage is available at the non-inverting terminal should be equal to inverting terminal. So since the non-inverting terminal is grounded, here it is also grounded. Because this resistance is having in between the zero potentials, no current flow is available across this one. So there is no use of this particular resistance 3 kilo ohm, or there is no effect of this 3 kilo ohm on the circuit. Now only you can able to see this is a part. It is exactly looking like the inverting amplifier circuit. Okay, so we can able to tell V out 1 is equal to the feedback resistance minus 7K by, and here the resistance 2.5K, it is multiplied with the input 5 millivolts. Okay, so what we'll get here, 2.5 is multiplied with 2, then we'll get here 5. So this is nothing but we'll get kilo will be cancelled. We can able to write here 14 millivolts. Okay, this is just the output voltage due to this 5 millivolts only. Now what we need to do, we will make this 5 millivolts is 0. That means here 0 volts is there. So there is no effect of this 2.5 kilo ohm. Now this 7K is connected to this one. Now here we will consider this 9 millivolts. So what will happen? V out 2 is equal to minus 7 kilo ohm by 3 kilo ohm. This is multiplied with here 9 millivolts. So in this manner we have to write. So now this kilo ohm will be cancelled, and here 3 ones are 3 3s are, so that you will get minus 21, 7 3s are 21 milli. Okay, so this is V out 2, this is V out 1. So total V out is equal to what we can able to write, minus 14 minus 21, that is equal to minus 35 millivolts. So this is the answer. Okay, then the work done by the conservative vector field, that is given by F bar is equal to YZ AX cap plus XZ AY cap plus XY AZ cap, or we can able to take I cap, J cap, K cap, in any manner we can able to write. That was given in the Cartesian coordinate system only. Along any smooth curve C joining the point A, which is from minus 1, 3, 9 to the point B, this is 1, 6, minus 4 is. Okay, that work done we have to calculate. So generally work done is given by, work done is equal to minus integral of F bar dot DL bar. This is the equation. Okay, so and they have mentioned here conservative vector field. Conservative vector field is nothing but in any path you calculate the work. Okay, that means point A is here, point B is here. You can able to calculate the work done through this path, or through this path, or through this path. In any path you calculate, you will get the same amount of work done. Then only we can able to say that is a conservative vector field. Okay, if this another point is also there, that is if A is equal to B, that means some path you are going and again you are coming to the same point. Now the total work done is equal to 0. Okay, so in the closed loop, okay, in the closed loop the work done is equal to 0. Then we can tell that particular vector field is a conservative vector field. So if I take here closed loop, then we can able to tell from A to A only you are coming. Okay, you are moving your charge from the point A, you roaming in some particular curve direction, and again you are coming to the same point. Then we can able to tell that total work done is equal to 0. Okay, but here they have given A is -139 and B is 16-4. So these 2 points are different. That's why we have to take the open line integral. So open line integral from A to B we have to calculate in this particular thing. Okay, so what is the procedure we are going to follow means here our intention is the charge has to be moving from -139 to 16-4. That means my starting point is -139. This is the starting point. From this point, first I will move to 139. What is the meaning of this one? Here what was done here? The charge has been moved from -139 to 139. That means I did not change the x coordinate. I did not change the y. Sorry, I did not change the y coordinate. That is 3. I did not change the z coordinate. That is 9. But I changed the x coordinate from -1 to 1. From -1 to 1 in the x direction the charge has been moved by maintaining y is equal to 3 and z is equal to 9. There is no movement of the charge in the y direction and in the z direction. It has been available at y is equal to 3 and z is equal to 9 only, but it has been moved in the x direction only. So what is available here? Only dx is available. And by maintaining this dx, we are having y is equal to fixed at 3 and z is fixed at 9. This was related to this particular thing. Now the charge is available at 139. Now the charge is available at 139. I am writing that one here, 139. Now what I am doing in the sense I am moving in the y direction. So x direction is fixed at 1 only, x value is fixed at 1 only, but y is changed to 6 because finally I need to move to this point B only where y is equal to 6. So here y value is changed to 6 and z value I am maintaining at 9 only. So in this particular case, which coordinate is changing or in which direction the charge is moving in the sense only y value is changing. X is maintained at 1, z is maintained at 9, but y value is changing. That means dy, and x is available at 1 and z is available at 9. So this is what we have to understand from this one. Now I will move in the z direction. So my charge is available at 1, 6, 9. Now I will maintain the x value at 1. I will maintain the y value at 6 and z value is now changed to -4. So in this particular case, what I have observed in the sense, x is fixed at 1, y is fixed at 6, but z is changing. From where to where the z is changing? 9 to -4. And here the y is changing from 3 to 6. Here x is changing from -1 to 1. Finally, if you see, we are at the point B. We are at, in the sense that the charge is available at, we have moved the charge from point -139 to 16-4. What we have observed here, first the charge has been traveling in the x direction and that is changing from -1 to 1. At that moment, we are fixing the y value at 3 and z value at 9. After that, we are moving the charge from 139 to 169. Now we are moving the charge in the y direction where the y is changing from 3 to 6. But we are maintaining the x value at 1 and z value at 9. And from this point we are moving the charge up to 16-4. Okay. So this is the thing we have to understand before solving the problem. After that we can able to go for the equation calculation, work done calculation. So here whatever the integral is there, that integral from a to b f bar dot dl bar can be splitted into 3 integrals now. So in the first integral it is changing, only x value is changing. Okay, only x value is changing, so that we can able to tell. Otherwise we will write f bar dot this particular dl bar, this is what we will calculate, or it is here x is changing from -1 to 1 and we are maintaining y is equal to 3 and z is equal to 9. So these values we will substitute here and here in this particular direction only dx ax cap, dl bar is nothing but dx ax cap only, because in this particular path here 3 paths are there. Whatever the given integral is there, okay, from a to b, this is split into 3 integrals now. First integral is related to this one, second integral is related to this one, and third integral is related to this one. So in the first integral only x is changing, that is nothing but dl is equal to dx ax cap. So this is x direction. Okay, in this x direction, what component of the f bar we have to take? Again this one only, yz only, yz ax cap only. That means here it is related to ax cap, so that we have to take here yz ax cap. Okay, but in this calculation where x is changing from -1 to 1, the y is fixed at 3 and z is fixed at 9. That means what we'll get here, y is equal to 3, z is equal to 9 means 27. So 27 integral, simply dx is there. That means what we'll get here, x only. Integration of 1 into dx is nothing but x, and limits are given by -1 to +1. So it is equal to 27 into x limits are -1 to +1 means 2, that is equal to 54. This is the value of the work available from -139 to 139. That means only in x direction we have moved. Now what we will do, we will get, it has to be added with, we will change y value, y is changing from where to where, y is changing 3 to 6. So y is changing from 3 to 6, but x is fixed at 1 and z is fixed at 9. Okay, this is what we have to consider. Okay, so here what is happening, and in this case y is changing, that means dl will become dy ay cap, dy ay cap. So dy ay cap means, see, in the f bar also we have to consider only y component, that is x into z. So this is equal to what we'll get, this is equal to x value is fixed at 1, z value is fixed at 9. So here simply dy is there, integral of 1 into dy means y only, and y limits are 3 to 6, that is nothing but 6 minus 3, that is 3 you will get. So it is equal to 27. Okay, now we will calculate the third one, that is integral z is changing from where to where, 9 to -4. So 9 to -4, but x is fixed at 1 and y is fixed at 6. Y is fixed at 6, and here dl will be given by dz az cap, dz az cap. So here also we have to take the z component only, that is xy az cap. So since x is fixed at 1 and y is fixed at 6, and the integral dz is nothing but z only, so z limits are from where to where it is changing, 9 to -4, that means -4 minus 9, upper limit minus lower limit. So it is -13 into 6, that is equal to 60 plus 18 means -78 we will get. So in the first path we got the work done, that is 54. Here I am writing, don't confuse here. So first path work is 54, second path work is 27, and third path work is -78. -78. So what we will get here, it is 70, 80, 81 minus 78, it is equal to 3. Okay, so this is the answer. Okay, so here's very simple thing. This is the equation you have to remember. Work done is equal to minus integral a to b f bar dot dl bar. Okay. Now Laplace transform of f of t is equal to cot inverse of s, then f of t. Okay, here this can be solved in this manner. F of t, they have given actually Laplace transform they have given. We have to calculate the inverse Laplace transform. That means the function was in s domain, we have to calculate the time domain function. That is nothing but what they have given, that I am writing now. F of s is equal to cot inverse of s. Okay, cot inverse of s, and this can be written as tan inverse of 1 by s. Tan inverse of 1 by s, like this we can able to write. Okay, so sorry, 1 by tan inverse of 1 by s. Then what we need to do, we can able to calculate here f of t by using the property called differential property. Differential property is nothing but d by ds of f of s is equal to, this one has to be differentiated. Okay, so tan inverse of 1 by s is nothing but, we know that 1 by 1 plus x square, that is nothing but 1 by 1 plus 1 by s square, like this we will get. And here if you take LCM, what we will get, s square by s square plus 1, like this we will get. Okay, it is d by ds of f of s. like this we got. Now what we need to do, we need f of t actually. So we have the this particular function, that is f of t is having the Laplace transform capital F of s. Capital F of s. When you have the differentiation in the s domain, what is happening in the time domain means you have to multiply with its variable. This is the property of the Laplace transform. If you perform the differentiation in the time domain, you need to multiply here with s. And here we have done the differentiation in the s domain. That means here you have to multiply with t. Like this we have to solve. So here you have this function. That means it is equivalent to minus t into f of t. So it is the Laplace transform for which function? Minus t into f of t. But what is this one? This is actually related to sine function. It is related to sine function, and you send this one this side. So what you will get? 1 by sine t by t. So like this will get. Okay. Next, the principle of homogeneity and superposition are applicable to linear and time invariant systems. Next, the Fourier series for the function f of x is equal to sine square x. Okay, what is the Fourier series for this particular function? That is what we have to calculate. Generally, Fourier series is given by f of t is equal to a naught plus sigma n is from 1 to infinity a n cos n omega naught into t plus b n sine of n omega naught into t. This is nothing but Fourier transform, trigonometric Fourier series. So here what we have to observe, cos functions can be available, sine functions can be available, and here integer multiples of the fundamental frequency terms are required. Here n omega naught is nothing but n is the integer, n is changing from 1 to infinity. So in that form we have to write this particular given function f of x is equal to sine square x. So that I am writing what they have given now. So f of x is equal to sine square x, that is equal to 1 minus cos 2x by 2. Okay, this is f of x value, and this can be written as 1 by 2 minus 1 by 2 into cos 2x, and what they have given means 1 by 2 is 0.5 minus 0.5 into cos 2x. It is exactly in the trigonometric functions only cos term is available, and where the omega naught is given by 2. Okay, we cannot say that is omega naught, n omega naught. Okay, that is equal to 2. So option D is the correct option. Next, the transfer function of the system is z of s, that is equal to v of s by s of I of s, that is equal to s by s plus 3. So I am writing that one, z of s is equal to v of s by I of s is equal to s by s plus 3. The system is at rest for t is less than 0. That means previous values for t is equal to 0 are 0. Okay, system is at rest. What will be the value of the v of t for t is greater than 0? For t is greater than 0, we have to calculate the v of t. If I of t is equal to 3 into u of t. This is what they have given. Okay, so where u of t is a unit step function, that already we know. So we need v of t, that means from this only we can able to get. So v of s is equal to s by s plus 3 into I of s. And what is I of s from this I of t? I of s is equal to Laplace transform of this particular function 3 into u of t. For u of t, what is the Laplace transform? 1 by s. That means 3 by s we will get. Okay, substitute here. So it is equal to s by s plus 3 into I of s is nothing but 3 by s. So ss will be cancelled. We will get 3 by s plus 3. 3 by s plus 3 is the v of s. But we need the time domain function. That means inverse Laplace transform we have to apply. Since already for the negative values of t there is no function. That is what they have given. That means we have to look for the positive values of t only. That means 1 by s plus 3 is nothing but the time domain signal is given by e power minus 3t into u of t. Okay, 1 by s plus a is nothing but e power minus 8 u of t. Like that we have taken. So answer is C. Next. So the 6 volts G0 diode shown in the circuit diagram has zero resistance and knee current of 5 milliamps. So here G0 diode is nothing but it is applicable for the voltage regulation. So it has to be operated in the breakdown region. So this is the characteristics. Here we can able to see this is the knee current. That is what they have given. That is 5 milliamps. So whenever the reverse current is equal to knee current or greater than knee current, we can able to say that particular G0 diode is available in the breakdown region. This is the breakdown region. Okay. So in the breakdown voltage they have given as 6 volts. This is the VZ or VBD, like that we can able to tell. That is the 6 volts. And the 6 volts we have to take like this. Here also 6 volts is there because that is there in the breakdown region. These two are in parallel. So in parallel, same voltage will be there. That is 6 volts. And knee current also they have given, that is 5 milliamps. Here 5 milliamps is flowing. Okay. So then what is the minimum value of the resistance R, so that the voltage across the diode does not fall below the 6 volts. Does not fall below the 6 volts means, so whenever the voltage across the diode is becoming less than 6 volts is nothing but it is non-breakdown region. That means they are asking us to keep within the breakdown region only. That means we have to maintain 6 volts only. That means the current should be greater than 5 milliamps, greater than or equal to 5 milliamps. So anyway they are asking for the minimum value of the resistance, so that we can able to take here 5 milliamps only. So through the diode here 5 milliamps is going, and here 8.5 is there, and across this one 6 volts is there. Now what we need to know? We need to know about this particular resistance value. So according to Ohm's law, V is equal to R into I. You know about this voltage 6 volts, and you need to calculate the resistance value. For that, what is required? How much current is flowing through this resistance, that is required for us. This has to be calculated. Okay, if you know I value, if you substitute here, you will get the R value. How to get I here? Here already you know 8.5 volts is there, here 6 volts is there, so you can able to find how much current is flowing through this particular 100 ohms. That is the supply voltage for these two branches. So how to calculate that one? So here the current is given by 8.5 minus 6 by the potential difference, 8.5 minus 6 by 100, that is equal to 1.5 by 100, that is equal to 15 milliamps. Out of this 15 milliamps, already 5 milliamps is taken by this diode. That means through this one how much current is coming? 10 milliamps. That means through the resistance how much current is flowing? 10 milliamps. So that what we can able to tell here? Here simply we can able to write R is equal to 6 by 10 milli. Okay, that is 0.6 K, that is equal to 600. So answer is B, 600 ohms we will get. Okay, then the voltage gain of the amplifier without feedback and with feedback, with negative feedback respectively are 100 and 50. So without feedback is 100 and with feedback is 50, and clearly they have mentioned that negative feedback. So that AF is equal to, we can able to write A by 1 plus A beta, where beta is the feedback ratio. Okay, so we can able to tell without feedback 100 is there, with negative feedback surely the gain will be reduced by the factor 1 plus A beta, so that we got here it is 100 becoming 50. Okay, now what they are asking? They are asking the feedback factor value, that is beta. So here you can able to substitute. It is equal to A is 100 by 1 plus A is 100 into beta. From this we can able to calculate the beta value. So here 51, 52 is 100. So 1 plus 100 beta is equal to 2, and 100 beta is equal to 1, and beta is equal to 0.01. Okay. Next, a point charge of Q coulombs, Q is equal to 20 into 10 power minus 9 coulombs. This is the charge value. Is placed at the origin. So charge Q is equal to, which is available at origin, that means 0, 0, 0, that is equal to 20 nano coulombs. It is 10 power minus 9 means we can take nano coulombs. How far along the negative x-axis? How far along the negative x-axis will be the potential? Here charge is available, charge is at 0, 0, 0, and here 20 nano coulombs charge is there. How far on the negative x-axis? The potential will be 60 volts. They have given the potential value, just we have to calculate the distance. So due to the point charge, the potential is given by, due to the point charge, it is equal to Q by 4 pi epsilon R. This is the equation. Electric field is changing as a inverse square law, that with respect to distance, but potential is changing as inverse of the distance only. Okay, electric field is changing as a square of the distance. Okay, inverse of the square of the distance, but potential is changing as inverse of the distance only. This is the thing we have to remember. Okay, so anyway here the question is based upon the potential. So here it is equal to, charge they have given 20 nano coulombs. Okay, and 1 by 4 pi epsilon we can able to take as 9 into 10 power 9, 9 into 10 power 9. So that one I am writing here 9 into 10 power 9, and we have to calculate the distance by R. And here potential they have given as 60. 60. So here unknown thing is the distance only, that is what we can able to calculate. 10 power plus 9, 10 power minus 9 will be cancelled, and here 21, 23 is a 60. So 3 r is equal to, we can able to get a 9 by 3, that is 3. Okay, 3 meters. So in this manner we can able to calculate. Next, the ramp function can be obtained from the unit impulse function at t is equal to 0. So unit impulse function is nothing but, it is like this, del of t. If you integrate this one, you will get u of t. U of t you will get, here 1 is available. So this is actually integration of del of t dt, and here t is equal to minus infinity to t you can able to take. And if you integrate this one, you will get the ramp function r of t is equal to, like this it will be there. So it is nothing but t into u of t, that means that one time integration of u of t, that means double time integration of del of t. This is what we have to do. Okay. Next, for a periodic signal, v of t is equal to 30 sine of 100t, 10 cos of 300t, and 6 sine of 500t plus pi by 4, the fundamental frequency in radians per second. Okay. So generally we know that whatever the sinusoids, whatever the cosinusoids are available in the Fourier series expansion, those frequencies are, the frequencies of all the sine terms or all the cos terms should be integer multiples of the fundamental frequency. If you observe here, 100 is available, 300 is available, and 500 is available. So these are the frequency components we are observing. So what we need to know in the sense, all these things are integer multiples of certain amount of fundamental frequency. What is that fundamental frequency? That is what we have to calculate. Okay. So here we can able to write this 100, 300 and 500. So for this one we can take, it is omega 1, it is omega 2, it is omega 3. For this one related time period t1 is there, for this one related time period t2 is there, for this one related time period is t3. So t1 is equal to 2 pi by omega 1, that is 2 pi by, we can take 100. Here related to this one 2 pi by 300, and related to this one 2 pi by 500. These are the 3 time periods. Now what we need to do, t1 by t2 we have to do. Okay, then what you will get here, 2 pi by 100, 2 pi by 300, that means 300 by 100, that is 3 we will get. Okay, then what we need to do in the sense, if you cross multiply this one, t1 is equal to 3t2. So t1 is nothing but what? T1 is 2 pi by 100, this is the overall time period, or 3 times of, if you do t2, then also you will get 2 pi by 100 only. That means for the first 2 terms we can able to say the time period is nothing but 2 pi by 100. That means what is the this particular frequency? For this one the fundamental frequency is given by, for these 2 terms only I am telling, that is 2 pi by t. 2 pi by t is nothing but 100 you will get. That means for these two, 100 is the fundamental frequency, and this 500 is also 5 times of 100. That means simply we can able to tell 100 is the fundamental frequency of this particular signal. Like that we can able to tell. Otherwise, simply we can able to see, by seeing the options, the minimum frequency out of all the options is 100 only. So 100 is the answer, because 100 into 1 we will get this one, 100 into 3, it is the third multiple of 100, it is the fifth multiple of 100. So integer multiples of 100s only, by seeing the options also we can able to tell, or by using this procedure also you can able to tell. Okay. Next, a function f of t is equal to sine of 1.1 into t plus sine of 3.3 into t. What is the time period? So this is here 1.1, here 3 times of 1.1, like this we can able to write. So it is 3 times of this fundamental frequency, that is nothing but omega is equal to 1.1. if you take, time period is equal to 2 pi by, we can able to take 1.1. Okay, so and according to this one you can able to write, it is 10, so here 11 and here 10 will come, so it is 5.5. So in this manner you can able to write 5 pi by 0.55. So in this manner you can do that particular calculation. Next, a band limited signal with a maximum frequency of 7 kilohertz. Maximum frequency they have mentioned as 7 kilohertz to be sampled. That means here to get the what we can able to say discrete signal, some sampling process has been done on the continuous signal, and that continuous signal is having the maximum frequency is 7 kilohertz. Okay. Then according to the sampling theorem, the sampling frequency in kilohertz, which is not valid. According to sampling theorem, what we can able to say, the sampling frequency must be greater than or equal to, or we can say greater than 2 times of the maximum frequency component. So that means it should be greater than 2 times of 7k. That means it must be greater than 14k. That means here option A itself is less than 12k. Okay, sorry, less than 14k. Here we should have greater than 14k. So option B is okay, option C is okay, option D is okay. Option B, C, D are having the frequencies which are greater than 14k only. So all these are valid. But they have asked which is not valid. That means 12k is less than 14 kilohertz. So that we can able to tell this is the right option for this one. Next question is related to digital circuits. The multiplication of the two binary numbers 1010 and 1101 is. So we have to multiply these two numbers, and first we can able to convert into decimal numbers. 1010 means this is 10, and 1101 is nothing but it is 13. So 10 into 13 is nothing but we know that is 130. So this 130 in decimal number. Now we need to convert into binary number. So different methods we know to convert into the binary number for this particular decimal number. So we can divide this 130 with 2 successive division process we have to make, and remainders we have to write. That is one method. Otherwise we can able to write like this. This 130 can be written as 128 plus 2. Like this we can able to write. Okay, why I have written like this means this 128 can be written as 2 power 7. So this 2 power 7 is nothing but 1 is followed by 7 zeros in the binary. So like this we can able to write. This is giving 128 and 2 is nothing but 10. So we can able to write like this. 1, 5 zeros, 1 0. That is nothing but option A is the correct option. Next question is convert the decimal number 185 into the hexadecimal. So we will apply the reverse process, that is from the options to this particular decimal number. So options, all options they have given in the hexadecimal. From the hexadecimal we can able to convert into decimal. How? In the sense we have to multiply with their weights. So for example, if you check for the option D, that is A8. So A8 is the hexadecimal number. So 8 into its weight is 16 power 0 plus this A is nothing but 10. 10 should be multiplied with its weight, that is 16 power 1. So what we will get here? 160 plus 8 into 1, that is 168 we will get. That means this is the wrong answer. We should get 185. Then if you take this one, that is option B, here B is nothing but 11. So 11 into 16 power 1 plus 9 into 16 power 0. Okay, so 11 into 16 is nothing but we will get 160 plus 16 is nothing but 176 plus 9 into 16 power 0, that is 9. So what we will get here? 185 will get. So 185 in decimal number system is equivalent to B9 in the hexadecimal number system. So option B is the correct option. You can check these two also. You will not get a 185. We have uploaded the questions related to all the subjects for this particular examination. Thank you.